Good morning. My name is K. Purushotham, working as Assistant Professor in the Department of Electronics and Communication Engineering from MLR Institute of Technology. So, today I am going to start the angle modulation. So, what I am going to cover today lecture is what is the angle modulation and what is the frequency modulation and what is the mathematical representation of the frequency modulation. So the first the angle modulation. The previous lesson we have covered about the amplitude modulation, DSBSC modulation and SSBSC modulation and related problems also we have solved. So today the angle modulation. What do you mean by angle modulation? Angle modulation is the process in which the frequency or phase of the carrier signal is varied according to the message signal. In angle modulation is defined such a way that where the frequency of the carrier or phase of the carrier is varied according to the modulating signal or message signal is known as the angle modulation. So the standard equation for the angle modulated wave. So once modulation process is completed, the output wave what we are calling modulated wave. That modulated wave can be represented as S of t. S of t is nothing but AC cos theta I of t is the modulated wave, where AC is the amplitude of the carrier signal, theta is the angle of the modulated wave. Theta I of t is nothing but angle of the modulated wave. The angle modulation further it is classifying into two types. The first one is frequency modulation, second one is phase modulation. What do you mean by frequency modulation? Frequency modulation is the process of varying the frequency of the carrier signal linearly with the message signal. So whatever the modulation technique we are taking, the carrier characteristics are changing according to the message signal. The characteristics are amplitude, phase, frequency. If frequency of the carrier is changing according to the instantaneous values of the message signal, that we are calling it as a frequency modulation. If phase of the carrier is changing according to the instantaneous values of the message signal, that we are calling it as a phase modulation. So let me discuss about the frequency modulation. Frequency modulation is similar to the amplitude modulation, but here frequency of the carrier we are changing. So in amplitude modulation what we are doing? The amplitude of the carrier signal varies. Whereas in frequency modulation, frequency of the carrier signal varies in according to the instantaneous values of the amplitude of the modulating signal. The frequency of the carrier is varying in accordance with the instantaneous amplitude of the modulating signal. So as a reference, what parameter we are taking? Amplitude of the modulating signal. The varying the characteristics of the carrier frequency according to the instantaneous values of the modulating signal amplitude is known as the frequency modulation. Hence, frequency modulation, the amplitude and the phase of the carrier signal remains constant. Only frequency of the carrier is changing. What are the other parameter? Amplitude and phase of the carrier is remains constant in frequency modulation. So if you take the graphical representation, so this is the M of t is the modulating signal and this is the high frequency carrier signal and this is nothing but modulated signal. So if you see here, the amplitude of the modulating signal is continuously varying according to the time. Message signal is not constant, it is a time varying signal. So the carrier signal is the constant signal. So the carrier is, it is also continuous varying, but the frequency what we are taking is same frequency, carrier signal. Okay. So the range of the frequency what we are operating in the carrier is some 88 to 198 megahertz. We are preferring bandwidth of the FM is So if you are taking some parameters of the FM, so the modulating signal of the FM is 15 kilohertz. Modulating signal of the FM is 15 kilohertz. So the band, FM band is lying within the range of 88 megahertz to 108 megahertz, and the IF value of the FM is 10.7 megahertz. So bandwidth of the FM we can calculate as per the Carson's rule. According to the Carson's rule, bandwidth can be defined as 2 into del F plus FM, or 2 into beta plus 1 into FM. So which is approximately 180 kilohertz. 180 kilohertz for the FM bandwidth. So here if you are substituting the value, here one more parameter, del F is the frequency deviation. As for the FM, it is having 75 kilohertz. So 75 plus FM is 15 kilohertz. So total is nothing but 2 into 90, which is nothing but 180 kilohertz. So the bandwidth of the FM is nothing but 180 kilohertz. So see here, whenever my amplitude of the modulating signal is high, so whenever amplitude of the modulating signal is high, the carrier, the compression is taking place. Modulated signal if you are taking, the carrier is compressing, means high frequency we are transmitting. Whenever the modulating signal is varying in the negative axis, that is low, so here the frequency is expanded. Compression and expansion. Expansion is nothing but the time period from year to year is less, the time period from year to year is high. So the time period from year to year is very low. Very low means T is 1 by F. The frequency is very high. Here high frequency we are transmitting the positive half cycle. Here time period is very large. Okay, T is very large means T is equal to very high. So F is equal to 1 by T. Okay, F is low. T is large means F is low. T is inversely proportional to the F. So whenever in the negative half cycle of the modulating signal, we are transmitting the low frequency signal. In the positive half cycle, we are transmitting the high frequency signal. As for the modulating amplitude of the message signal, the carrier signal frequency is varying. So this modulation we are calling it as a frequency modulation. Why means frequency of the carrier is varying according to the modulating signal. According to the modulating signal. So that we are calling it as a frequency modulation. So here when amplitude of the modulation, so see here the frequency of the modulated wave increases when the amplitude of the modulating signal increases. Frequency of the carrier is increasing whenever amplitude of the modulating signal is increasing, and frequency is decreasing whenever the amplitude of the modulating signal is decreasing. When amplitude of the modulating signal is 0, what is the signal we are transmitting? Carrier signal, FC we are transmitting. Okay, whenever modulating signal is 0. So how we can represent mathematically the frequency modulated wave? So we know the frequency modulated wave, though Fi, instantaneous values of the frequency, can be represented as Fi is the instantaneous frequency of the FM modulation. So it is nothing but Fc carrier frequency plus Kf m of t. Kf m of t. So Fc is the carrier frequency, Kf is the frequency sensitivity, m of t is the modulating signal or message signal. So now the angle modulated signal, we know the S of t. We know the S of t. S of t is nothing but AC cos theta I of t, theta I of t. So first let me take omega I. Omega I is the instantaneous frequency, can be represented as a d theta I of t by dt. So here omega I is nothing but 2 phi fi. Omega I is nothing but 2 phi fi. D by dt theta I of t. D by dt theta I of t. So I am representing as theta I of t, theta I of t d by dt is equal to 2 phi fi, 2 phi fi. So what I am doing? I am performing the integration on the both side. I am performing the integration on both side. So what we are doing? Integral. So here theta I of t d by dt will be cancelled. So integral 2 phi integral fi of fi dt, integral fi dt theta I of t value we are getting. So we know fi. What is the value? 2 phi integral fi. Fi is nothing but fc plus kf m of t dt. 2 phi kf m of t dt, which is nothing but theta I of t, which is nothing but theta I of t. 2 phi integral fc plus kf m of t dt. So if you are expanding theta I of t, so what is the value you are getting? 2 phi fct, 2 phi fc integration. So integral of 2 phi fc dt plus integral 2 phi kf m of t dt. So here what is the value you are getting here? 2 phi fct plus 2 phi kf integral m of t dt, which is nothing but theta I of t, theta I of t. We know the modulated wave. We know the modulated wave, that is s of t. S of t is nothing but AC cos theta I of t. So if you are substituting the theta I of t, AC, if you are substituting the theta I of t, AC cos theta I of t is nothing but 2 phi fct plus 2 phi kf integral m of t dt, integral m of t dt. That is the s of t expression. This is the equation of the fm. This is the equation of the fm. But in a fm, what is the modulating signal? Modulating signal m of t is nothing but am cos 2 phi fmt. Am cos 2 phi fmt. So the equation can be modified AC cos 2 phi fct plus 2 phi kf integral m of t is nothing but am cos 2 phi fmt dt. So what is the expression? Finally we are getting AC cos 25 FCT plus 25 KF. Integral of cos theta is nothing but sin theta, that is, sorry, this is AM sin 25 FMT sin 25 FMT divided by 25 FM. So finally AC cos 25 FCT plus 2525 KF AM by FM sin, this is sin 25 FMT 25 FMT. So the final answer what we are getting is AC. The final answer is AC cos omega CT plus beta sin 25 FMT where KF AM is nothing but del F. KF AM is nothing but del F. So beta is nothing but modulation index. Beta is nothing but modulation index. Modulation index is equal to del F by FM. Modulation index is equal to del F by FM, where KF is the frequency sensitivity. Frequency sensitivity. AM is the amplitude of the modulating signal. Del F is nothing but frequency deviation. Del F is frequency deviation. The value what you are taking is 75 kilohertz in the FM. Predefined value what you are taking is 75 kilohertz in FM. So the frequency deviation del F, the variation of the frequency deviation according to the modulating signal, we are calling it as a frequency modulation. So here finally S of t expression can be represented in two ways. One way is S of t is equal to AC cos omega CT, AC cos omega CT, that is another 25 FCT plus 25 KF integral 0 to t m of t dt. Okay, the integration what you are taking is 0 to t. The integration what you are taking is the positive half cycle only, we are concentrating 0 to t m of t dt. So other way representing m of t, if you are taking am cos 25 FMT, so another expression for the FM modulated wave is nothing but S of t is equal to AC cos omega CT plus beta sin omega mt or 25 FMT. Okay, this is the expression, mathematical representation of the frequency modulated wave. So the FM wave, again it is classified based on the value of the beta. Based on the value of the beta, whether beta greater than 1 or beta less than 1. Beta less than 1, we are calling it as a narrow band modulation system. If beta greater than 1, we are calling it as a wide band modulation system. So beta value is small. Generally the beta value less than 10 we are taking, which is narrow band modulation system. Beta value greater than 10 we are preferring as a wide band modulation system. So the narrow band FM. So what is the narrow band FM? The frequency modulation has the smaller bandwidth compared to the wide band FM. So the narrow band FM bandwidth is equal to the, in narrow band FM bandwidth is equal to 2 FM. Small bandwidth is required, same as the amplitude modulation bandwidth. So the narrowband FM bandwidth is smaller. Why? Means the modulation index is small. The spectrum consists of carrier, the upper sideband and the lower sideband. Here the spectrum, how we are getting the spectrum? If you are applying the Fourier transformation for the time-domain representation of the signal, we can get the spectrum of the signal. The spectrum, what is the use? We can calculate the bandwidth of the signal. We can calculate the bandwidth of the system also. Okay, so that is the main purpose of the applying the spectrum and applying the Fourier transform for the time domain signal, which is converting into the frequency domain signal. From the frequency domain signal, we are obtaining the spectrum of the signal. So frequency representation of the particular signal. The spectrum consists of carrier signal, upper sideband and lower sideband. That is nothing but similar to the AM only. So that's why the bandwidth is also equal to the 2 FM. So where we are using this one? We are using in the mobile communication such as police, wireless and ambulance system, taxi, cabs, etc. We are using the narrowband FM. And coming to the wideband FM, the beta value is far greater than 1. So greater than 10. Generally the beta value is greater than 1 or greater than 10 we are preparing. So that we are calling it as a wideband FM. So wideband FM, here it is having the infinity number of sidebands. So the bandwidth is also very high. So the bandwidth generally we are calculating 2 into del F. The bandwidth for the wideband FM we are calculating is 2 into del F. So it is having the infinity number of sidebands, and we are using this, the carry infinity number of sideband which located around it. So it is used for the entertainment and broadcasting applications. We are using it as for entertainment and broadcasting applications such as FM radio and TV applications, etc. We are using this one. So next coming to the what are the advantages of the FM? So the FM is less affected by the noise compared to the AM. Why FM is less affected by the noise? FM we are dealing with the carrier frequency. We are not dealing with the amplitude of the modulating signal. In AM, so the envelope, it is concentrating on the envelope of the signal. So envelope is more effective for the noise. So here FM we are concentrating on frequency of the carrier is varying according to the modulating signal amplitude. So that's why it is immune to the noise. It is less affected by the noise compared to the amplitude modulation system, and provide clear audio reception. The FM we are using for the sound applications. So clear audio can be obtained by using the FM. Next, higher signal to noise ratio. So the FM signal to noise ratio is higher. So signal quality is greater than the noise. So higher signal to noise ratio means which one is the one of the most preferable and important desired component in the communication system. If we are maintaining the high signal to noise ratio, we can transmit the signal for the longer distance without degrading the performance of the signal. So that's why most of the in TV applications we are preferring the FM only. Better sound quality due to the reduced noise effect. Signal to noise ratio if you are maintaining very high, automatically the quality of the signal is improved. So the noise effect is automatically decreasing and better quality of the sound we can obtain. So constant transmitted power, carrier amplitude remains constant. So transmitted power does not vary with the modulation. So the carrier power FM, what is the power? PT in the FM is nothing but AC square by 2. AC square by 2. The amplitude, carrier amplitude remains constant. Carrier frequency is varying, but carrier amplitude is not varying. In the FM, phase and amplitude of the carrier remains constant in the FM. So that's why the transmitted power does not vary with modulation. And capture effect, FM receiver can suppress weak signal and receive the strong signal clearly. So wherever nearby any disturbance is there, the disturbance signal we are not concentrating, only the strong signal only we are concentrating. So high fidelity, suitable for high quality audio broadcasting such as music transmission. So the music transmission applications which is providing high fidelity, for that applications we are using the FM. So next, what are the disadvantages of the FM? So as per the advantages, and there are some disadvantages also there. So the large bandwidth, as the beta value is very greater than 1. So the spectrum of the FM, that is infinity number of sidebands are located in the both sides. So large bandwidth is required. So FM required much more bandwidth than the AM. So the bandwidth as per the Carson's rule, is what I have calculated just now, is 2 into del F plus FM. And one more parameter is complex equipment is required. FM transmitter and receiver more complex than the AM. More complex than the AM. And limited coverage. So FM is affected by the line of sight. So due to that, short range only we can transmit. But AM we can transmit for long range. So threshold effect, below certain signal level, receiver performance degrades rapidly. Okay, below there are some threshold value is there, below the threshold value signal degraded rapidly. And what are the applications of the FM? FM also we are using for the broadcasting. AM and FM, most of the broadcasting applications we are preparing. And television, for sound transmission we are using the FM. Two-way radio communication, that is police, wireless and ambulance systems we are using the FM. And mobile communication also we are using, and satellite communication also we are using. So this is the about the FM. The today lecture what I have covered is what is the angle modulation and what is the frequency modulation, what is the phase modulation. Angle modulation is nothing but the changing the characteristics of the carrier signal, changing the characteristics of the carrier signal according to the modulating signal. So if carrier frequency we are changing, that we are calling it as a frequency modulation. If the phase of the carrier is changing according to the instantaneous values of the modulating signal, that we are calling it as a phase modulation. So angle modulation again we are classifying into two types. One is the frequency modulation, another one is the phase modulation. And we have defined what is the frequency modulation and what is the phase modulation. Then we are concentrated what is the mathematical description and mathematical expression for the angle modulated signal. So we obtain the angular modulated signal S of t is equal to AC cos into 2 pi fct plus 2 pi kf integral 0 to t m of t dt. That is the one expression. Another expression is nothing but S of t is equal to AC cos omega ct plus beta sin omega mt. That is the second expression. Then what are the advantages of the frequency modulation? We have discussed it. What are the disadvantages of the frequency modulation and what are the applications of the frequency modulation? Okay. The next session we will explain what are the different methods we are using for the generation of the narrowband FM and wideband FM. Thank you.